there are no questions over the previous assignments, we'll go on and start today's lesson. You're welcome. Now, the conjugate root theorem with the real polynomial coefficients, well, a plus bi, its conjugate is going to be a minus bi. So the conjugate theorem is saying that if a plus bi's conjugate is a minus bi. The conjugate root theorem is just saying if a plus bi is a root or a solution, then a minus bi will be also. So a plus bi's conjugate is a minus bi. We're really just changing the sign in front of the imaginary part of the complex number. So what's the complex conjugate of 7 minus I? What do we think? That's it. Because a plus bi's conjugate is a minus bi. And a minus bi's conjugate is a plus bi. So let's look at the next one. Negative 5 minus 5i's complex conjugate would be? And that's it. Questions on this so far? Now, what is interesting with these conjugates, if we multiply them together, so if we take 7 plus I and multiply by 7 minus I, let's see what we get. Well, 7 times 7 would be? 7 times negative I would be negative 7I. I times 7 would be plus 7I, and I times negative I would be negative I squared. Well, this negative 7i plus 7i will cancel because that's going to be 0. 7 minus 7 is 0. 7i minus 7i would be 0. Well, what did we say I squared is? So negative 1. Really, we would have negative 1, which is just, it gives us 50. So if we multiply 7 plus I times 7 minus I, we get 50. I mean, the conjugate is just 7 plus I. If we multiply the two together, we get 50, yes?
So do we have to have that?
If it asks for both, then yes. But that's kind of interesting because if I multiply them together, what happened to I? It simplified out, didn't it? Because these canceled out and I squared became negative 1. Do I have I anymore? And that's what's nice about these complex conjugates, is that when they are multiplied together, the I terms go away. They cancel out. And that's why we can have one of them as a solution, because we need both. They come in pairs. Because when they are multiplied back together, they do cancel out. Any questions on this here? So what's the complex conjugate of negative 2 plus 4i? Are you ready for the next two? 10 minus 2i. Right, because we're just mainly changing the sign in front of the bi term. Any questions on this here? How about negative 4 minus 3i? And 8 minus 3i would be? What would the complex conjugate of negative 9i be? Yeah. Because how could we also see this? We could also see it as 0 minus 9i, yes? So its complex conjugate would be? How about the complex conjugate of 8? Just be 8. Because it would be the same as plus 0i, which would be minus 0i, but it's still just 8. Any questions on this here? You ready for what's next? Division. Now, we can't leave imaginary terms in the denominator. So we have to simplify it out so that we don't have I in the bottom of the fraction. And this is where our complex conjugates come in. As we just saw, and we dealt with at the beginning, if I multiply 1 minus 2i by its complex conjugate, all of the i's will simplify out. We won't have I anymore. It'll just be a number. So what we can do with this fraction is multiply it by the denominator's complex conjugate. So what is the complex conjugate of 1 minus 2i? So we're going to multiply top and bottom by 1 plus 2i. So on top we'll have to do the distributive property. So we'll do 4 times 1, which is 4. 4 times 2i is plus 8i. 3i times 1 is plus 3i. And 3i times 2i is plus 6i squared. We can do the same thing with the denominators. 1 times 1 would be 1. 1 times 2i is plus 2i. Negative 2i times 1 would be negative 2i. And negative 2i times 2i would be negative 4i squared. Any questions on this so far? Well, in the denominator, 2i minus 2i is 0. What did we say I squared was? Negative 1, yes? So really, this I squared cancels out and just makes this plus 4. Negative 1 times positive 6 would be not positive 6 anymore, but negative. It's just changing the sign. Now, if it's just I squared, it becomes 1. Because really, what are we saying here is what? 6 times negative 1, which is, here we're just saying we have 4 times, or negative 4 times negative 1, which is just positive 4. Now on bottom we now have 1 plus 4 because the I is gone, which gives us. Now on top we have 4 minus 6 because those are now like terms, which is. And 8i plus 3i is. Now with these here, we'll want to split them apart into the real and imaginary parts, the part with I and the part without I. Now we can do this when we do have two things added together on top. We can split them apart, added or subtracted, from each other. Now the denominators would both be 5. What would be our first numerator? Well, and the other one would be 11i. And that'd be our answer. Now, if we could simplify it down, if there was a common factor on top and bottom with either 11 and 5 or 2 and 5, then we would simplify it. But here, since there's not one, we leave it as this here. Now, we do pull the I out to the side, so we have it in the form of A plus BI. But just keeping it in standard form of A plus BI. Any other questions on this here? So what would we be multiplying the top and bottom of this by? Over? Yes. Because we're going to multiply the top and bottom by its complex conjugate of the denominator. So we multiply through the numerator. 1 times 2 is 1 times negative 3i would be negative 3i. Negative 4 times negative 4i times 2 would be negative 8i. And negative 4i times negative 3i would be plus 12i squared. Now we can look at the denominator. 2 times 2 is 4. 2 times negative 3i would be negative 3i times 2 is plus 6i, and 3i times negative 3i is negative 9i squared. Well, I squared, we know it turns into negative 1, so it's really changing the sign in front of it from negative to positive. Now in the numerator, well, it's going to change the sign in front of 12. Well, it's already positive, so it's now going to be negative. Also in the denominator, negative 6i plus 6i is 0. So on the bottom of the fraction, we're left with what? 4 plus 9, which is? In the numerator, 2 minus 12. Negative 3i minus 8i is negative 9. And we have this here. Any questions on any of this here so far? And exactly, well, we can, yes, because we do need to split this apart into our two fractions. Here we would have negative 10 over minus 11 over 13 I. Now 10 and 13 won't reduce, 11 and 13 won't reduce, so this is the final answer. Could we plug this in the calculator? So how can we go about plugging that last one in? What would we do first? Alpha y equals enter, and then we have 1 minus 4i over 2 plus 3 second I. And what happens when we hit enter? Okay. Now, this calculator here is a little bit more advanced because it's the color edition. They did add this feature in. Let's try typing it in a different way. Let's say parentheses, 1 minus 4 second I close parentheses. Now, what are we realistic?
I need the afternoon Votech kit to go down to Algebra for your senior pictures.
What are we doing here? We are dividing, yes? What are we dividing this by? 2 plus 3 second I. Now we get this here, yes? Division? Divide, yep. Now, how can we turn these back into fractions? We can do what? Math. Enter. Isn't that the same thing we just got when we worked it out? Yeah. So it can do it. These calculators can do it. We just have to turn it into division. We can't have it using alpha y equals. It won't like it. It won't let us do it that way. Any questions on this here? Well, let's go on and look at the next one. So if we wanted to type it in, it would be 2 plus 5 second I, close parentheses, divided by, what would we type in next? Four second I, and then we can go math, enter, enter, and it'll tell us that it's 5/4 minus 1/2 I. And that's it. Now, with these here, you do need to put the parentheses around the denominator. You do need to put the parentheses around the denominator. Even though it's just a single term, even if we do delete it, did it give us the same answer? Yes? No? What changed? And the 1/2 is now positive. Because what it did is it took it and divided by 4 and then multiplied through by I. So it gives us a different answer. So we do need the parentheses around the denominator, even if it is a single term. Because if we work this out, we would really just be multiplying the top and bottom by negative 4i. Negative 4i times 2 is negative 8i. Negative 4i times 5i is negative 20i squared. And the denominator would be negative 16i squared if we multiplied it out. This I squared would make the 16 positive. This I squared would make the 20 positive. Which at this point, if we broke it up, we would have 20 over 16 minus 8 over 16 I. Well, 20 over 16 would reduce to 5/4. 8 over 16 would reduce to 1/2. Well, that there doesn't it match up when we had the parentheses around it? Yep. So we need those if we're going to get the right answer. Questions on this here? Y'all need to see another example of one of these. Okay. Which one? This one? Okay. You want to try it by hand or in the calculator? So you can plug it in the calculator. We'll do it. I'll show it both ways. But if we're multiplying this, we'd multiply top and bottom by the conjugate, which would be 4 minus 6i. Now the numerator, 7 times 4 would be 28, minus 7 times negative 6i would be negative 42i. The denominator, 4 times 4 would be 16. 4 times negative 6i would be negative 24i. 6i times 4 would be plus 24i. And 6i times negative 6i would be negative 36i squared. So the I squared would simplify out and turn the 36 from negative to positive. Now negative 24i plus 24i would be 0. So the denominator, 16 plus 36, would be 52. In the numerator, we would have 28 minus 42i. So that would be 28 over 52 minus 42 over 52i. Now we do need to simplify this if we can, because 28 over 52, because 2 will go into both, because that would be 14 and 26, the same with this here, 21 and 26. Because that could reduce to 7 over 13 minus 21 over 26. 4 plus 6i. Now, if we grab the graphing calculator, now we may or may not need the parentheses around the 7. What is it? 4 plus. Okay. 6, second, I, close parentheses, enter. Okay, well, it gave me a fraction. Is that what we got? And that's it. Now, with some of these here, even if you're not sure if we need the parentheses or not, go on and put them. Because having them and not needing them won't hurt. If you need them and don't put them, it can change the answer. But any other questions on this? Any other ones that we want to see worked? That's fine.